Welcome to our live webinar, How to Remotely Configure Connectivity for Improved Security and Efficiency. Today's webinar is hosted by Automation.com, PTC Kepware, and JPI Solutions. Thank you for joining us. My name is Renee Bassett, Chief Editor of Automation.com, and I will be the moderator for today's presentation. Before we get started, I would like to acquaint you with an important feature of this GoToWebinar technology that we've all logged into. On the right side of your screen, you will see a Questions tab. To send us a question, click in the text box, type your question, and click Send. All submitted questions are seen only by the presenters, and at the end of the presentation, we will answer as many as we can while keeping to the overall presentation time of 1 hour. If we run out of time, the questions will be forwarded to our panelists for future response. Also, please note that at the end of today's program, we will ask you to complete a brief post-event survey. We appreciate your time giving us feedback so that we may improve your next experience. Today's presentation is about remotely configuring connectivity for improved security and efficiency. OPC servers and other remote connectivity options are critical to implementing digital industrial solutions such as SCADA, MES, or industrial IoT. Many of these solutions need local access for configuration, which means network administrators must provide controls or SCADA engineers with otherwise unnecessary access to machines on the operations network. These solutions also require repetitive steps. Configuration APIs enable both remote and bulk configuration, and they can be used to implement a, quote, least privileged permission set. Configuration APIs also let advanced users create custom configuration clients. Today you will learn about configuration APIs from two presenters. The first is Dustin Sims, SCADA Vice President for JPI Solutions, a systems integrator and automation solution provider based in Alberta, Canada. Second is Jeff Bates, Director of Product Marketing for PTC Kepware, developers of industrial connectivity software. They will introduce and explain the Server EX Configuration API and discuss two advanced use cases that allow JPI to quickly implement critical connectivity for their customers' operations. So, without further ado, take it away, Justin.
My name is Dustin, and I'm with JPI Solutions. And we are an Industry 4.0 system integrator based in Alberta, Canada. We work with oil and gas customers, helping them get data from field to corporate. And we have recently experienced good growth as a new company, growing from 1 person to 10 in just about 2 years. Our experience with OPC servers and connectivity goes back to 2012. We have worked on many SCADA systems, large and small. Some of our client systems only have a few remote devices, others have thousands. Kepler is one of our partners in accomplishing the mission of efficiently moving data from remote devices to SCADA and beyond.
Great, thanks, Dustin. I am Jeff Bates. I lead product marketing for the Kepware line of business within PTC. And I'll also just give a quick intro to Kepware for those who aren't familiar. And really the key point on this slide is that the Kepware business has been focused solely on industrial connectivity for close to 25 years now. As you can see here, we started in discrete manufacturing, but have since expanded to a number of different industries that are all listed here in the middle of the slide. And we continue to grow as well. And when I say industrial connectivity, I do want to define that a little bit, but also want to see how familiar folks are with that term. So I think we have a poll question, and if you can fill that out now, that'll help us cater the content for the rest of the webinar. Great. So it looks like a pretty even split. There are some folks, 20% of folks, who are not familiar with industrial connectivity solutions at all, and then a smattering of folks who are familiar with different types of industrial connectivity. So we'll go through and talk through exactly what we mean when we say industrial connectivity here. If we can switch back, perfect. Thank you. So with industrial connectivity, we're really talking about two major connectivity challenges. One is that devices in the industrial space tend to, or have tended to in the past, rely on proprietary protocols. That's certainly changing. There are newer devices that are starting to standardize on protocols like OPC and having OPC UA baked into them. But for many, many years, most of the automation devices that were found on a plant floor would use proprietary protocols. So very dissimilar from an IT environment where you might just expect to have APIs or might expect to have everything standardized on something like DDS. So just the very act of getting the data off of those devices can be, or at a certain point in time, was very difficult. And then the second challenge is really architectural. Those automation devices, PLCs and RTUs and others, are designed to automate a process and not designed to communicate. But an enterprise may have 10 or more different applications that need data, and those automation devices are often expected to play a dual role. If the automation device is receiving 10 requests, 10 different requests for data every 300 milliseconds, then the CPU load on that in terms of communication is just going to get too high. And certainly there are devices that have features that protect against that, but even in that case, in the case where a device is dedicating a certain portion of its CPU to communication, that if there are 10 applications hitting it, that can still lead to a lot of network traffic and downtime, even due to overloading the network. So what happened in the 1990s was OPC servers kind of came on the market. The OPC Foundation developed the OPC specification, and OPC servers started showing up to solve both of these problems. And it's been really widely adopted by industrial applications. Any SCADA system or MES system or historian that is addressing this space is likely to communicate over at least OPC-DA, and more frequently you're seeing these types of applications utilize OPC UA, which is the new and sort of modernized protocol from the OPC Foundation. And OPC UA has a number of different advantages that I won't go into too much detail here, but has modern security and is much easier to set up and authenticate than OPC-DA. And so that is how, in the 90s and until today, or until a couple of years ago, how industrial companies were getting connected. Today, there are a number of additional options in terms of getting connected. Many OPC servers and other communication solutions have added other means of connectivity like MQTT, REST, some of these IT-centric protocols, ODBC or direct integration into a SQL database. So that's a little bit of the evolution. Well, that's what we mean when we say industrial connectivity, and that's a little bit of the evolution of the space. There are certain challenges with those tools, especially with OPC servers, in that most of them, and the ones that we'd like to focus on today, are related to local configuration. With most of these OPC servers, you have to have direct access to the server or machine that the OPC server is hosted on in order to configure it. And that has a number of challenges that I'll run through quickly here. One is that if that machine is difficult to get to, or in a DMZ, or just not accessible, it requires using, in the case of Windows, it requires using something like RDP, or other similar tools. And it's not to say that RDP is not secure, but essentially you are opening up another tunnel and another attack vector to the server when you're using a tool like that. And for a lot of these OPC servers, you really need administrator access to that server or machine in order to do the things that you need to do. So that is, and we've even heard stories of people going through multiple RDP tunnels and jumping from machine to machine with RDP, and it can get very complicated. So that's one downside. Similarly, only in a lot of these solutions, only one user can configure the server at a time. And what invariably happens is somebody leaves the configuration open on their machine and goes home for the day, and somebody else who needs to configure the connectivity solution is not able to log in and do what they need to do. And then lastly, with the GUI configuration, in a lot of cases there are, you want to make a bulk change. You want to change a property on 100 tags across 10 different devices, and that can just get repetitive clicking into each of those things. So luckily, modern tools or modern OPC servers and modern connectivity solutions are adding ways to remotely configure their solutions and to alleviate some of these issues. And one example of how that's being done is via a configuration API. And for those who aren't familiar, an API stands for Application Programming Interface. And it's essentially, it allows two applications to communicate, or any application to communicate with another. And it really eliminates the need to build a custom integration to a product. And so these application APIs, in order to be useful and accessible, need to use common architectures, common protocols. And so the configuration API that we're going to talk about today, the one that is included with Kep Server EX, relies on the RESTful architectural style, which is generally used and widely used on the web. And we'll go into these in a little bit more detail, but there are 4 key commands that are used with a RESTful configuration API. And I'll just introduce them here quickly. So the first is a GET. It's really just a request for information. You're getting information from the server. The second is a PUT. It's really an edit command. You're editing an existing object. And to do that, you pass in the properties that you want to edit. There's also the ability to post, which is how one creates a new object. And similarly there, you're also required to pass in certain properties that govern the creation of that object. And then lastly, delete is just what it sounds like, removes an existing object. And so as I said, the put and post commands require passing certain properties into the server, and the server needs to have a common language to identify that. And in this case, the configuration API relies on the commonly used JSON format. So to show folks kind of how it works from a very basic perspective, we have a demo. And what we'll do in this demo is to illustrate really one of the first things that customers want to do when they open any OPC server or connectivity solution, which is just to create a connection to a device, which you might imagine. In KepServerEX, that requires creating a channel to that device, identifying the device itself, and identifying the tags to connect to in that device. So we'll do a demo of creating a channel device and tag in KepServerEX using the configuration API. In this case, we're going to access an instance of KepServerEX on the local machine just for simplicity's sake. And with a few minor changes, we could configure the API to connect to a remote instance of KepServerEX, but we'll leave that out just for the sake of time. And it's important to note that the demo uses, again, the HTTP protocol, RESTful services. In a production environment, users will need to configure HTTPS, which adds TLS security on top of HTTP. And then lastly, we'll just note that the demo uses, or that in order to interact with the configuration API, users are going to need to use an HTTP client with authentication capability. And in this example, we use Postman, which is a third-party software. And I'll just say that because it's not Kepware or PTC software, we can't make any guarantee on quality, availability, or security. And so without further ado, let's dive into the demo. So as you can see, I have KepServerEX installed on my local machine here. But now I want to start interacting with the configuration API. So to do that, to get started, I will right-click on the administration icon here and go into KepServerEX settings. And in order to interact with the configuration API, I first have to enable it. So enable is set to yes. And in this case, I do want to use HTTP. And all the other settings I can leave as default. So the first thing that I can do is to click on this link that says View in Browser. And this is going to show me documentation. Most importantly, to start, it's going to, if I click on the documentation link here, it's going to show me all the endpoints that I can interact with. And it'll show me not only the endpoints, but the actions or the commands that I can send to them to get results. So here I can get information. As we said, the get command is to return information. And at this endpoint, I can get information about the project. But probably more interesting, I can get information about the channels. And as you see here, I can also post to this endpoint to post to create a new channel. And so that's what we'll do. But first, let's get information back about the channel. So I can actually just copy this endpoint. And as I said before, we're going to use the HTTP client Postman, which I have installed here on my local machine for simplicity. And I will paste that endpoint into Postman. I also need to get down to the exact endpoint that I want. So if I want information on channels, I will paste this endpoint here. Importantly, I need to set up authorization for this request. And to interact with the configuration API, I need basic authorization. I want to interact with the configuration as an administrator, and I have not set up a password. So with that, I have the authorization that I need. I'm making a GET request, and I want information on my channels. So if I send that, I can see that I have all of the channels that I would expect in my sim demo project. So now I want to create a channel. As I said, that requires a post to create a new object versus a put, which is to edit an existing object. And I also need to supply some information to the configuration API to set up a channel. So in order to do that, I'll switch back over to the documentation and I'll click into the supported drivers page. And I want to create a channel that is using the simulation driver. So here I'll go down to the simulator and I'll take a look at some of the properties that I'll need to include to create that channel. And so first I need to include a name for this channel. So in order to do that, I will copy this over into Postman. and I'm going to edit the body of the request. And to do that, I need to add a JSON payload to this request. I do that by choosing JSON here. And I'll put in that property of common all types name. And then I can name the channel whatever I want. In this case, I will call it demo. The next thing that I need to include, I don't need to include a description, I can leave that blank. But the next thing I do need to include is what type of driver I want to use for this channel. So I will copy this over, paste there. And as you can see in the documentation, if I switch back here, I want to use the string simulator, bring that back, and paste it here. And these are the only two properties or parameters I need to supply to the channel or to this endpoint in order to create a channel. Everything else can essentially be left at default. And that's going to vary depending on the driver that you're using. But for the simulator driver, I only need to provide a name and the type of driver that I want to create. So I'm doing a post to the channels endpoint. I'm giving the channel a channel name and a driver type. And if I send that, I get a 201 created. And I can check to make sure that that channel was created in a couple of different ways. Because I'm on the same machine, I can actually just go back to the configuration and see that a demo channel was created. But if I'm remote and I don't have that ability, I can also do a get on the channels again to see whether or not the channel was created. And as you can see here, I do have this new channel called demo. And here are all the different properties that I could change when I'm making a channel. So if I wanted to change any of these now that I've got the channel created, I could go back, I could do a put and just copy and paste any of these items into the body of that put request. So now I want to create a device underneath that channel. So if I go back to the endpoints, then I can see how that works. So if I want to create a device, then I need to create it underneath a channel, obviously, and the endpoint is just going to be that same endpoint that I had earlier with channels, and the name of the channel that I want to create a device underneath, and then devices. So I'll go back to Postman, and here put in my channel name again, and that's just demo, as we know, and then also put in devices. Now, I could do a get on this, but since I just created that channel, I know that there's not going to be any devices underneath it. So I'll just do another post. Now I need to supply some parameters. If I go back to my documentation, under the supported driver section, and down under the simulator driver, I have a list of device properties, but the only ones that I need to include for creating a device for the simulator driver are again, the name of the device, as well as what type of driver I'm using. Everything else you can certainly include, and in most cases, for many other drivers, including the Modbus driver, you would need to include a device ID, but in the case of the simulator driver, this is all that I need to include. So if I go back over to Postman, I'm going to give this the name of demo device, and it's still a simulator driver. Again, I'm posting to the devices endpoint, and if I send that, then I get a 201 created. Let's use the configuration API to see whether or not it was actually created. Again, I'm doing a get to get information on the devices underneath the demo channel. And I hit send, and I can see that my demo device is created. Again, I have a list of properties that I can now edit if I need to. And so lastly, I'm going to go ahead and create a couple tags. Let's go back to the documentation. Tags is a little bit of the way down the page, but if I see here, This is the endpoint where I can get information on or create new tags. And again, it's channels and then the channel name, devices, and then the device name, and then tags. So I'll just bring that over to Postman again. So my device name is demo device. I already have the channels and the channel name in there, and then tags. And for tags, I again need to create a name for the tag that I'm creating. But instead of telling the configuration API what the driver type is, I need to tell it the address of the tag. And this is the property for doing that. And so for the simulator driver, you can find more information on the addressing scheme of that driver in the help files. But I know if I need to create a ramp tag, then I can just create the address R1. And instead of calling it a device, I'm going to call it demo tag 1. If I do a post with this payload to this endpoint, then I'm going to get a 201 created. I'll just do another one. I'll do a constant tag, which is just K1, and I'll create demo tag 2. And then if I do a get on the tag endpoint, it comes back and shows me that I've created 2 tags. And just to confirm that everything worked, I'll go back to my configuration, show that I've got a demo channel, demo device with demo tags 1 and 2. And if I open up the quick client, then I can see I've also created this new demo channel with a demo device, which has tag 1 and tag 2, and I'm connected. Dustin, I'll pass it over to you. I guess I'll just kind of conclude my portion by saying that remote configuration of OPC servers and other connectivity solutions enables users to improve security by avoiding that RDP connection or additional remote connections into the product. It enables folks to enables multiple concurrent configurers of the product, which just makes things a little easier across the organization and avoids any hiccups due to folks not logging out of the configuration. And it enables bulk configuration, which Dustin will go into in a little bit. So without further ado, Dustin, I'll pass it over to you.
My demo is demonstrating how we use the API to mass build a project for a client. One of the best parts of using an interface like the API in Kepler is creating scripts or programs that enable automating the creation of a project. We made use of this workflow on a project completed last year for a client with over 1,000 devices. Kepler's API requires that data be sent and received using JSON strings, which is a common thing to do with HTTP-based APIs. The content and format of the JSON string is well documented, and you can browse the various fields available for reading and performing configuration by navigating to the API's URL. And it describes a fair bit about how to get to channels and devices. So before we get started, I'm going to make sure that we have a blank Kepware project to work with. Perfect. Now our client was using USS. USS is a legacy OPC server that is commonly used with oil and gas systems. This software is no longer in support, so that necessitated the upgrade. Configuration for USS is stored in a proprietary database, making it harder to manage lots of devices and get at the info. Luckily, the software provided a convenient CSV export, and this export function allowed us to export all the configured channels and devices to text files. So this is an example of what the USS export looks like. They've got 2 main object types, circuits, which are like channels, and devices, which are exactly like devices. And as you can see, the export has the naming and connection information required to set up all our devices. So with our exported configuration and knowledge of the JSON strings, we set about writing some Excel macro code that cleans up the export files and prepares the JSON strings that we can interface with Kepler. This data cleansing took some trial and error at first, but the export files have a consistent formatting, so we prevailed. Here's what our cleaning tool looks like. I have some data already in here from a previous project, but our Excel workflow basically includes copying and pasting the export data into the USS circuits and devices tabs, parsing and copying out the data. This is an Excel macro. It actually pulls out the name and channel information and puts it on the right sheets. We did a little bit more cleaning and reorganizing of some of the data. As you can see, the IP is in the channel, but we needed it in the device to work with Kepler. We did some sorting and of the data to remove any blanks, and we combined, using a macro, we combined all the data into a JSON string, so you can see that here on the right. And this is what a device one looks like. And then we took and applied the configuration of Kepware using the API. So I'm just going to rearrange this here so you can see both the tool and Kepware at the same time. And I'll open up the controls. So we'll create all the channels first, because devices need a channel to attach to. And you should see in Kepware, you'll see the logger go and tell you that the REST API is working. And then you'll see all those channels created. And then we'll create all the devices. And this will take a little bit longer because there's roughly 1,000 devices here. And you'll likely see the configuration app reload the project a couple times through this process. There we go. Now we've got all these devices. And if we look at the properties of these devices, you'll see it pulled the description information out and it pulled the IP and port information out. And we have a rough project that's ready to go. All right, we did have another use case here. I couldn't get a video put together, but we have a bulk edit tool that connects to the API and can do bulk changes on the fly. You can read all the devices out and change scan rate. If you wanted to scan every 5 minutes instead of every 15 minutes, we can do a bulk change with the API. And then, yeah, if we want to open it up to some questions now.
All right, well, we can open it up to questions now. So just as a reminder, if you have any questions for either Dustin or Jeff, you can use the panel on the right-hand side and submit your questions, and we will, I will cover as many as we can with them. One basic question that somebody asked for understanding is, what's the difference between a device and a channel?
Yeah, that's a great question. Yeah, absolutely. So a channel is really setting up a path to the device, which is how we talk about it. So inside the channel object is where you're going to set up, whether or not that channel is a serial channel or an Ethernet channel. And, you may think, hey, there's not too many serial devices that are still out there, but in a world where devices are running for 10 or 20 years, there's actually still a fair amount of serial devices out there, or devices that need to be communicated with over a serial connection and not an Ethernet connection. So that's different. It's really setting up, hey, here's the protocol that I'm going to use. The transport protocol, Ethernet versus serial, as well as the application protocol, whether that be Modbus or Common Industrial Protocol or Siemens Industrial Ethernet Protocol. That's what the channel is defining. And then the device is separate from that. The device is actually, as I said in the demo there, the device is actually defining the IP address of that specific device and device-specific properties. How many times do I want to try and reach out to that device before I assume that it is no longer connected, that type of thing.
Great, thanks.
Another question we have is, what authentication protocols or methods are supported when using the API? And is there a way to limit access by device groups for different users?
Yes, absolutely. So, and Dustin, I'm hoping you can chime in here. But you can configure the server to authenticate against the Kepserver EX user manager. So you can set up different users, and then in the user manager within Kepserver EX, you can also define whether or not they have configuration access. And so where I put in those basic authorization parameters, you would be able to put in to authenticate as a specific user that has certain configuration capabilities or permissions. So with that, you could say, hey, under a certain user only has the ability to configure devices under channels 1, 2, and 3, and doesn't have permission on channels 3, 4, and 5, and that goes all the way down to the tag level. Dustin, is there anything that I missed there? Anything you want to add?
No, I think you got it all. Like the authentication is just your basic web page authentication, username, password, and then inside the user manager, you can tell the software what permissions that user has and what channels and devices.
Okay, well, we have another question about Postman and what's the role of Postman, and would you mainly use Postman for test scripting?
I'll take that one, and I would say yes. Postman is a great tool for figuring out how things work and how to test your scripting. Depending on what you're doing, you may find it really cumbersome to do lots of edits or things with it in production. So we use it in-house for a lot of the testing and figuring out how to get the code working first.
Okay, thanks. How does Kepware interact with wireless sensors and IoT gateways?
That's a great question. I can take that one. So unfortunately, IoT Gateway is not particularly well defined. So I've seen IoT gateways defined as, you've got, in some certain cases, an industrial PC that is defined or marketed as an IoT gateway. And in that case, if the industrial PC can run Windows, then Kepserver EX can actually run directly on it. But I think probably the question was around interacting with wireless sensors and IoT gateways that are aggregating information from a number of sensors. And there's a number of companies that we're familiar with and we've worked with, and that we've worked with to develop an integration. And a couple of those are, I'm gonna forget a lot of them, but Labellium and B&B SmartWorks, which is owned by Advantech now. And we actually have a webinar on how we integrate with the wireless sensors from B&B SmartWorks. And for both of those solutions, they provide an IoT gateway that speaks or that communicates over the MQTT protocol. And we recently, a couple of releases ago, implemented I guess it's not so recently now, but a couple of releases ago, we implemented a new driver called the MQTT client driver. And that enables Kepserver EX to ingest data over MQTT and pass it up to SCADA systems or any other applications, pass it up to cloud-based solution or any on-premises industrial application. So the Dell IoT, it looks like that person clarified, and they're looking at the Dell IoT Gateway 5000. I'm not sure I'm familiar with the Dell IoT Gateway 5,000, but I believe, if I'm not mistaken, that is similar to something like the HPE Edgeline or other industrial PCs. And if those devices run Windows, then KepServerEX can actually run directly on those boxes.
Okay, great, thanks. A slightly more higher level question. We had one listener who said this is a great way to create bulk devices and had a question about architecture. How many Kepware servers should you consider per factory?
Yeah, and I think Dustin and I can probably both speak to that. You know, the real answer is it absolutely depends. You know, in many cases, or in some cases, you know, KepServer EX has been configured with you know, close to a million tags. So that for some factories will cover that that entire factory. In certain cases, there are a lot of advantages to having to kind of multiplexing that and having multiple instances of KepServerEX. There are some companies that even go as far to have a single instance of KepServerEX for a single work cell or a single line. But again, it really depends on the configuration, on the environment, and what the customer is trying to do. I don't know, Dustin, if you have anything to add there.
No, the standard "it depends" answer seems to be the best here. But yeah, it really depends on what you're trying to accomplish, and if you are trying to aggregate data for an entire facility and bring it somewhere to get it up to an MES system or to an ERP system, maybe one instance works. Or if you're using it locally for an operator display, maybe having a single instance for a work cell works. And in my world, in oil and gas, we're typically doing 1 or 2 instances for a really large set of remote devices. Yeah, it just kind of depends what's going to work best, and maybe a little bit on how the network architecture is.
Great, thank you. Back down into the details a little bit. Dustin, we have a question about what drivers are exposed in the API.
Just about all of them, I think. So if you go to the web page that Kepler serves up, it shows all the different drivers that are available there. And last time I checked, pretty much every driver that was in Kepler is available to be edited with the API.
Great, thanks. This question's for Jeff. How does Kepler update the configuration API? How often, excuse me, I read it wrong.
Yeah, so good question. We update with essentially every release, making sure not to break the contract, so that to enable backward compatibility. But in the next release of the product in 6.7, I can share that we actually do have a number of updates to the configuration API where we're adding additional advanced plugins that we can configure, and adding the ability to configure some of the administrative settings. So we continue. We released the configuration API with KepServerEX version 6, which went live in November of 2016. And as Dustin said, at that release, it was able to configure most of the KepServerEX drivers and a handful of plugins, and we continue to add functionality to the configuration API.
Great, thank you. Any options to store data from sensors to the hard drive or the cloud for later accessing?
Yeah, that's a good question. There are a couple of examples, and again, it's going to depend on what you're doing. So again, the the real focus of Kep Server EX is on that connectivity piece. You know, we don't want to be a enterprise class historian. We really just want to focus on the connectivity piece and enabling folks to use their data. So one option would certainly be to utilize a historian type product locally, which there are a number of options out there. If you wanted to use a database, we also have the ability to send data from Kep Server EX into a database. And we do have, I will mention, we do have a product called the local historian, which utilizes the OPC HDA protocol. But in a lot of cases, folks are more comfortable and familiar with databases, so you can set up as I said, a database, a local database that Kep Server EX will send data to. But again, I think the it depends answer is appropriate there. It does depend to a certain extent the amount of compute that you have available at the edge locally, as well as a couple of other factors. I don't know, Dustin, if you've seen that type of configuration or have experience with that type of thing.
We've done a little bit of work with the IoT Gateway module. So you can configure your device, send some tags and a schedule to inside Kep Server EX to grab those tags on a regular basis and publish using the IoT Gateway to Azure or AWS or different cloud providers.
Yeah, good point. So oh, okay, yep, sorry, that's the question was to the hard drive or cloud. So the IoT Gateway obviously enables connections to the cloud, Azure, AWS, as Dustin said. And in terms of sort of local storage, it does have the ability to cache tags locally to be able to send up to the cloud when the connection is resumed.
Gotcha, thanks. A specific question asking if it's possible to integrate Kepware with Node-RED.
Yeah, absolutely. And we actually have a couple of demos of that on our website. I believe the first video we had was an integration with Node-RED that allowed us to send a tweet with Kepware, a little tongue-in-cheek, but a good illustration of how that works. And that integration is most easily done with the IoT Gateway. And I guess I should just introduce the IoT Gateway product. It's one of those products that enables connectivity over the more IT-centric protocols. So it has an MQTT agent in it, as well as a REST client and a REST server, so that you can send data over those protocols to client applications that are expecting data in that format. So AWS, Azure are included in that, as well as just to a web page that would use REST. So in the case of Node-RED, I believe that product has the ability to ingest data over MQTT, and so that's how we've done it in the past.
Great. Based on sensor data to the cloud, how is the control signal communicated over the channel to control a device?
Yeah, good question. So that is the MQTT, and in most cases, I'm going to use MQTT because in most cases it is MQTT that's being used with the popular solutions such as Azure or AWS. And in that case, you have the ability to configure the connection as read-write. So writing to a tag, as long as it's in the expected format, will write all the way back down through Kep Server EX and back down to the device. I will also note that same user manager and security policies tool that I mentioned earlier, and enables you to set that up so that there are certain tags that can be written to from the cloud, or not be, that can be allowed or disallowed by an administrator of Kepserver X. Dustin, I don't know if you want to elaborate there. Really, the writing is managed by the protocol itself. In the case of MQTT, it's a read-write protocol.
If there's no answer from, nothing more from Dustin on that, we do have a question about, for either of you, have you done implementations in high availability applications with server redundancy, etc.?
Well, I've done a few where the SCADA host software is redundant, but Kepware is not. We've got one system where Kepware is also set up on both the main primary server and the standby, but we end up manually syncing the Kepware piece because it doesn't change very often.
And then, yeah, certainly there's a number of implementations that we as Kepware have done with redundancy, and there's a handful of different ways to go about that. I personally have not. I leave that to our very competent application engineers, so I can't go into too much detail there. But certainly, if that's something that you're about to embark on, then please reach out to our application engineering team, and I can facilitate that introduction to make sure that you're using best practice.
Great. Well, we're just about to the end of our hour, and we want to be mindful of people's times. But so I have just a couple of questions here. We did have one about, we did say we will be sending out the demos with the email that comes after this session. And we had a question, is the VBA source code example for the channel device addition through the RESTful API going to be made available either through this webinar or on the support site?
That's a great idea. We hadn't planned that, but it's definitely something we can look into.
Thank you. Lastly, that looks like it's just about it. Those are all the questions we have in. As a reminder to everyone, as I said, we're going to be sending out those demo videos so you can have more information there. And I would like to thank both Dustin and Jeff for their participation today, and all of you for your thoughtful questions. If you missed any portions of the webinar or would like to rewatch the recorded version, that email that we send out will have a link to the recording with additional links for more information. We'll also be sending out a post-event survey that will appear requesting your feedback, and we'd appreciate it if you gave us that feedback so we can make the next one better. This concludes today's program, and thank you all and have a great day.